So for the next session, again, we invite oral presenter. For next presenter is Miss Veronica Norman from Atmajaya Catholic University of Indonesia with the title In Vitro Study on Tempe Oil Micro Emulsion containing omega-3 for protection of Alzheimer disease. Uh, Miss Veronica Norman, 10-minute time is yours.
Hello everyone, before I start my presentation, let me introduce myself. I'm Veronica Norman Andina Maha and I'm an undergraduate student from Atmajaya Catholic University. It's a great honor for me to have a chance for presenting to you about my research with topic in vitro study on tempe oil microemulsion containing omega-3 for protection of Alzheimer's disease. Alzheimer is one of causes dementia that affects memory, thinking, and behavior. Based on WHO data in 2015, there is 46.8 million people living with dementia, and this number estimated will double increase every 20 years. Hippocampus Hippocampus that have responsible for think and saving memory had shrinkage in people with Alzheimer. The shrinkage of hippocampus is because presence of tau tangles and plaque beta amyloid, which affects the lack of signal communication between neurons in our brain. That's why it's important to us to maintain our brain health. The simple way we can do is consume tempeh. Tempeh is a fermented food from soybeans and it's original from Indonesia. The process of making tempeh is submersion, boiling, drying, and adding rhizopus. Tempeh contain antioxidant and omega-3 which proven to prevent Alzheimer. And oil of tempeh can be formulated in microemulsion. But after being formulated, does tempeh oil ability to prevent Alzheimer can still play a role? And this is my purpose in this research, to formulate tempeh oil in form of microemulsions and analyze its molecular ability as an anti-Alzheimer agent. Microemulsion is dispersion system consists of an oil phase and water phase stabilized by surfactant and co-surfactant. And the characteristic of microemulsion is stable, keep the content of antioxidant and omega-3 tempeh, good penetration ability, solve the solubility problem, and overcome the unpleasant smell of oil tempeh. For the general method, first we did the sample preparation, and then after that the tempeh oil, we do the formulation with the microemulsion formation, and then we analyze the stability and organoleptic uh, from our microemulsion product, and then we do the analysis gas chromatography and then efficacy analysis with the enzymatic and antioxidant analysis. And for the in vitro, we do the cell culture treatment first and then cytotoxic analysis, RNA extraction, cDNA synthesis, and gene expression analysis. And then this is the genes or the biomarkers of Alzheimer's that we analyze in gene expression. For the extraction of tempeh oil with maceration method, we get from 5 gram tempeh resulted as much as 3.5 milli extract of tempeh oil. And then from the analysis gas chromatography, formulation 1 and formulation 2 contain the omega-3 and omega-6, which have ability in prevent Alzheimer's. And then for the enzymatic analysis on inhibiting acetylcholine esterase, formulation 1 and formulation 2 have a higher concentration of ACHE than tempeh oil, and galantamine is used as a positive control. And for the inhibiting butyrylcholine esterase, formulation 1 and formulation 2 showed the ability to inhibit this enzyme. ACHE and BCHE are enzymes that break down the acetylcholine or ACH, which ACH will bind to receptors and act as neurotransmitter signal in cholinergic neuron. In Alzheimer's pathology, increased activity of ACH and BCH to break down ACH can affect flux of neuron signal in cholinergic neuron. And then for the antioxidant activity, we do with FRAP analysis. And the result is formulation 1 and formulation 2 showed the higher activity of antioxidant compared with omega-3 as a positive control. And then for the gene expression, after giving a treatment from formulation, showed increasing expression of NTRK and BDNF genes, which NTRK and BDNF are genes that are responsible in cholinergic system, but in Alzheimer's pathology, these two genes are decreasing. And for the expression of APP and BACH genes showed after treatment with formulation, there is decreasing expression of these genes. APP and BACH are the genes that roles in formation of beta amyloid. And at the beginning presentation, I already told that beta amyloid is one of factor causes of Alzheimer. And the last is TNF. TNF is the gene that responsible in inflammation expression. And then in Alzheimer pathology, there is increasing of TNF. After treatment with formulation, the result is formulation with 50 concentration showed the decreasing of expression of this TNF. The conclusion of this research is the tempeh oil can be formulated in microemulsion form and then can inhibit ACHE and BCHE and still contain omega-3 and omega-6, which is support the characteristic of microemulsion that keep the content of omega and antioxidant of tempeh and then had an antioxidant activity. And then microemulsion product can increase the expression of NTRK and BDNF gene and can decrease or downgrade the expression of APP, TNF, and BACH genes. That's all from me. Thank you.
Okay, thank you very much for your presentation, Ms. Veronica Norman. So for the next presenter is Miss Devi Anggreni Putri that she attend in this room. Okay, so if you can have her, so I will going to the Miss Apriana Noni Ramhawati from Universitas Erlangga with the title Synthesis and Study Molecular Docking of 4-steryl dehydrotetrazolipyrimidine derivative compounds as anti-cancer candidates. For Miss Aprianoni Ramhawati, 10 minutes for your presentation. Time is yours.
Okay, sir. Thank you. Okay, first I want to say thank you to Mr. Rico for the time. In this opportunity, I want to presentation about my master research with the title is Synthesis and Molecular Docking of 4-steryl dehydrotetrazolipyrimidine derivatives as anti-breast cancer candidates. This is for the introduction. Breast cancer is the dangerous cancer especially for women. And then year by year, the death rate is always increased. So this is the previous study that study about anti-breast cancer from the Xiao et al. 1998. So in my compound has a similar structure with molecular target. This is the first dihydrotetrazolopyrimidines, given name as MTDPTS. And then in my research, I do synthesis and study molecular docking with protein data bank 3ERT, that is human estrogen receptor alpha. This is a receptor target. And then I hope my compound can be anti-breast cancer candidate. And then this is the synthesis of target molecules that have 3 reactant. There are ethyl acetoacetate, 5-amino-1-tetrazole, and then cinnamaldehyde derivatives. With the catalyst is PTSA, and then the solvent is ethanol. This is the 6 of result of my compound synthesis. There are MTDPTS 0 till 6. There are 7 compounds. It has a similar substituent. With substituent is electron donating group and electron withdrawing group. And then this is the method of synthesis of target molecules. For the first is ethyl acetoacetate, 5-amino-1-tetrazole monohydrate, cinnamaldehyde derivatives, and PTSA dissolved in ethanol, and then doing reflux in the solvent temperature. And then the reaction control with thin layer chromatography, or we can call TLC. And then after the precipitate forms, doing work up with the cold ethanol and distilled water. And then the precipitate was filtered using a Buckner funnel. And then the measurement, the weight, and then doing the structure characterization of the compounds. And then the in silico test. This is the molecular docking procedure. For the first is extraction of human estrogen receptor alpha S receptor from the protein data bank with the code ES3ERT, and then extraction of 4 hydroxytamoxifen as a ligand, and then preparation of receptor and ligand using Gaussian 16, and next determining the size and position of grid box, and then redocking process, and then result analysis. If the value of RMSD less than 2, docking process is considered successful. And then docking molecular target with the receptor is PDB3ERT. And then the ligand is my compound MTDPTS 0 till 6 using doc6. Docking result analysis is for free binding energy and receptor ligand affinity. And then the result and discussion. For the first is result of the synthesis of molecular target. There have two data. There are reaction time and yield. And then the best data is for the compound that has substituent is nitro, MTDPTS3, with the reaction time is 2 hours and the yield is 63%. And next, this is the data of UVV spectra. For all my compounds, it is the have maximum wavelength of sterol according to the literature range from 240 till 300 nanometer. So this is the lambda maximum of my compounds. And then for the FTIR spectra, to determining the functional group, this is the wave number in the measurement and the reference. It is suitable with the reference in its functional group. And then the HNMR spectra. This is the one of my compound that no substituent, MTDPTS0. And next, this is all of the data of proton NMR spectra. And next, this is the carbon NMR spectra. For the MTD-BTS0, there are 8 signal for CH or CH3, and the 6 signal for CH2 or C quaternary. This is the 7 data of carbon NMR spectra for my compounds. And then this is the data of high resolution mass spectrometry. So from the data, we can conclude the molecular formula, DBA, and the M per Z theoretical and M per Z measurable value. And then this is the result of molecular docking. For the grid box, has a grid spacing in 0.3 Armstrong. And then this is the grid center and the grid dimension. So in the redocking process, has a result for RMSD is 0.504 Armstrong. So this is can call successful for redocking, so can continue to docking process. And then this is the result of docking process from the EH compound that has the result is negative value for the free binding energy. And then the inhibition constant is so small. Inhibition constant is a concentration to inhibit the receptor target. So I can conclude that my compound in MTD-BTS3 with the configuration is R is the most best result with the free binding is -40. This is the better than the Legion original, this from 4-hydroxytamoxifen that has value for free binding is -37. And then this is the result for the active site binding from the asam amino acid with compare with Legion for hydroxytamoxifen and Legion molecular target. There are so many binding. And then the conclusion is the first sterile dihydrotetrazoolopyrimidine derivative synthesis with electron withdrawing group substitute aromatic aldehydes require faster reaction and higher yields than electron donating group. The result of the study molecular docking MTD-BTS 0 till 6 compounds against human estrogen receptor alpha showed a negative free binding energy with a small average inhibition constant. These results indicate that the complex formation can occur spontaneously and the compounds MTD-BTS 0 till 6 can inhibit the action of estrogen receptors. For sterile dihydrotetrazoolopyrimidine derivative compounds have potential as anti-breast cancer candidates with better results, namely compound with R configuration. That's all my presentation. Thank you very much.
Thank you very much for your presentation, Miss Abrina Noni Rahmawati. So now is we going to key and answer. So in the chat box, I got two question from the Risky to Miss Veronica. So he asks about why you choose 5' for your research, and then how the relation among your primer that you have with the Alzheimer disease. Miss Veronica, maybe you can deliver some answer to this question. Miss Veronica, are you still here? Miss Veronica. Okay. So if say we're going to further to second question to Miss Apriana Noni. Ms. Teo asks you about the question. Uh, what relation between your target molecule with the UVC spectra? Could you please address this question?
Okay, thank you, Mr. Tio, for the question. I want to answer. The UVV spectra is to determining the sterile group for my compound because this is the core of the compounds in my compounds. Sterile is the core compounds. So it is very important to determining first.
Okay.
That's all, Mr. Rico.
Okay. So I would like to call Miss Veronica. You still in this room? Miss Veronica Norman.
Okay, sorry, I'm here, Mr.
So I have some question from the Mr. Rizky that he asked you about why you choose 5' for your research, and then how the relation among your primer that you have with the Alzheimer disease. Could you address this question?
Okay, I get this question. Okay, thank you for the question, Mr. Tio. In this study, we propose for hypothesis for HD protection, like oxidative stress and oxidative stress pathway, enzymatic inhibition towards ACH and BCHE, inflammation pathway, and genetic. Thus, these 5' were selected as the representative gene markers related to this for HD hypothesis. For example, like NTRK and BDNF, which genes that have specific regulating mechanism of activation and regulating signaling in brain. And NTRK have TRKB receptor, which active with BDNF to resulting brain signaling. And then for the APP and BACA gene, is have a specific roles to form beta amyloid, which beta amyloid is a main causes of Alzheimer, and for the TNF is a represent gene marker of HD cause inflammation, and that's the explain why I choose these 5 primers.
Okay, thank
Thank
you
you.
very much, Miss Veronica, for your answer. So this is the last of the our parallel section. So before we are closing, so I would like to make a photo session. Could you please all the past division for the turn on this that video? Okay, we will take some photo for documentation. Please open and please turn on your video, the camera. Okay, okay. Okay, I would like to keep your what that I will count. It's ready. So 1, 2, 3. Okay, once more. 1, 2, 3. Okay, thank you very much for your attention today for our presentation. So I remind all participants to leave the breakout room, but not push the Zoom meeting. So we go to the main uh, the, the main session to be announced of the breast presenter. Okay, so we meet in the main room. Thank you very much for your attention. See you for further or in the future conference. Thank you very much.
Thank you, Mr. Rico.